Section 5.4. I feel like I could explain it a little bit better than the book can. So here we go. So rational functions. So there are a couple characteristics that we have here. Notice that here, like going vertically, we have this sort of break in the graph where we have like the left part of the graph, the right part of the graph. And also horizontally, we have like the top part of the graph and the bottom part of the graph. We have two different asymptotes. And what an asymptote is, it just tells us where the graph is going along that asymptote. Often it will not cross the asymptote itself, but it sometimes will. And that just happens whenever we break the graph up into a couple of different pieces. But for right now, let's graph these just as is. I have a couple of tricks that we could use to graph these. And that's going to be these right here. So I would take a screenshot of this so that way we could have it in our notes somewhere. But we're going to use these here to help us graph rational functions. So the very first thing is going to be our vertical asymptote. And we have that vertical asymptote here going up and down. So vertical asymptote, that's going to happen when our function is undefined. And our function is undefined when the denominator equals 0. So if we have a function, let's just keep it with that, the function that we have graphed, 1 over x. So with the function that we have graphed, it's whenever the denominator is equal to 0. So here we're literally just going to grab the denominator, set it equal to 0. So x equals 0 in this case. Let's see what it looks like on that graph. So x equals 0. And it's that vertical asymptote cutting the left part of the graph from the right part of the graph. And next, actually, let's just do a split screen really quick. The next part is going to be our horizontal asymptote. That's determined by the end behavior. And if you remember what the end behavior was in the previous section, it was where the graph ends up going. So since we have our functions broken up into like the top and bottom, numerator versus denominator, that's going to help us determine what our end behavior is. So for the most part, we're going to have a horizontal asymptote. So just that horizontal line breaking up the top part of the graph from the bottom part of the graph. So here, let's create a couple of rules over here. So vertical asymptote, we mentioned when the denominator, or set the denominator equal to 0. So set denominator equal to 0. For the horizontal asymptote, it's determined by our end behavior. So what we could do to solve for that part is get a ratio of the leading terms in the numerator and denominator. So ratio of leading terms So ratio of the leading terms in the numerator and denominator. Our y-intercept, evaluate the function at 0. So let x equal 0. So there, that one's easy. So is our x-intercept. I feel like we've been doing those this entire semester. So when x equals 0, our x-intercept, evaluate our function equal to 0. So here we're just going to say when y equals 0. And then I mentioned that it's not going to cross our horizontal, or we might cross some of the asymptotes. Let's take a look at our options. So vertical asymptote, denominator equal to 0. So what we're looking for is where the function is undefined. So when the function is undefined, we will never actually end up there. So we'll never have this cross. So we'll never cross our vertical asymptote. There are times where we'll cross our horizontal asymptote. So that's why I make in one of the questions crossing horizontal asymptote or crossing any of the asymptotes for that matter. The only time we're going to ever cross the asymptote is possibly at the horizontal asymptote. So set function equal to horizontal asymptote. An abbreviated HA, horizontal asymptote, is equal to our function. And then we solve. So then we solve that. If we do cross at all, this is where we're going to see it. If we don't cross at all, if we have no solution, then our graph actually never crosses that horizontal asymptote. And now I feel like I have to put this last part in just so we know, we remind ourselves to actually pick a couple of more points, because what eventually happens is we have a majority of our graph completed. Let's say we have a couple points here, horizontal asymptote here, and we know that we're going to cross, our graph is going to cross somewhere over here, but we don't really have any points to see where the graph is at this part of the stage. So what we would have to do is find a couple of points over here. So if we find a point here, if we're above the asymptote, then we know our graph is going to go here. If we're below the asymptote, we know that our graph is going to go somewhere down here because we know we're not crossing any of the horizontal, any of the other asymptotes. So that's how we're going to graph these, and stick around for the next video to see a couple of examples. If you have any questions, please feel free to ask. Otherwise, bye.